Hello, good morning, good afternoon, good evening, everyone. It's my pleasure to be here today to discuss about branches of AI. Artificial intelligence is a branch of computer science, and the main focus of AI is on creating systems that can perform tasks, those tasks that require human-like intelligence. So we want to somehow mimic the human intelligence. There are too many algorithms proposed to solve such tasks that need human-like intelligence. We can categorize the AI algorithms into four main branches. The first one is problem solving by search. Second one is knowledge, reasoning, and planning. Third one is learning, and fourth one is communication, perceiving, and acting. For each branch, there are too many proposed algorithms, and in future lectures, we will study them one by one. Absolutely, we have no time to study all the algorithms. However, for each branch, several algorithms will be discussed. The first branch of AI is called problem solving by search. Search is a fundamental problem solving technique in AI, and the goal here is to systematically explore a space of possible states. We want to find a space of all possible states as well as the actions, and we want to find a solution. For example, we want to find the path from initial state to a goal state. So search in AI is used to solve problems where the solution involves a series of steps or decisions that we want to take. So there are many even sub-brands in here. For example, we have uninformed search, we have informed search, we have adversarial search, and we have constraint satisfaction. In the coming lectures, we will study all, and for each one, we will study one algorithm. So the famous algorithms here are, for example, depth first search. DFS explores as far down a branch of the search tree. Later, I will explain what is search tree. And we want to go as far as possible before backtracking. And DFS uses a stack of remember the path it's exploring. So what are the applications for DFS? For example, solving mazes, puzzles, and also finding path in simple graphs. We have also breadth first search. DFS try to explore all nodes at present depth level, and maybe you can say shortest path finding, web crawlers, and social network analysis are here. Then we have hill climbing, least cost search, adversarial search, backtracking search, heuristic search, and expected max. So we will study all one by one in the coming lectures. So here you can see one example. We want to solve this puzzle. So the ultimate goal here, we call this one as start state. It means our puzzle is in this state, and the goal state is we want to sort them 1, 2, 3, 4, 5, 6, 7, 8, right? So this 8 puzzle problem is a well-known example of state space search in AI. So in here we can see how AI algorithm systematically explore and evaluate states in order to find an optimal solution. The optimal solution here is we want to reach to the goal state with minimum number of moves. So such techniques are widely applicable in robotics, pathfinding, and game. For example, here in this state, 3 possible actions are there. We can move 7 here, so it means 7 come down, right? Or we can say, so if we move the 7 down, we will be in this state. If we move 8 up, then we will be in this state. And if we move 6 to the left, we will be in this state. Then all possible state, this is called as search tree, right? This will be go to finally we reach to the goal state. So later we will study them one by one. So this was the first one. The second one is knowledge, reasoning, and planning. In AI, knowledge, reasoning, and planning play a crucial role in enabling agents to make informed decisions. A rational agent must have knowledge about the environment and also its actions effect, using logical reasoning in order to maintain and update knowledge as new information arrives, and also deduce action that will help achieve its goals. So here, for example, you can see one example here for reasoning example. We say that all humans are animal, right? And animals normally eat and drinks. Then how you can prove that a human eats and drinks? In here, we will proceed with logical deduction based on the given premises we have. Two premises we have. From the first one, we know that if X is a human, X is animal as well. And in the second premise here, we know that if X is animal, then X used to eat and drinks. By combining these first and second premises using modus ponens, we can say that if X is human from premise 1, then X must be an animal, and if X is animal from premise 2, then we can conclude that X eats and drinks. Therefore, if X is a human, X eats with what we aim to prove. So, using modus ponens, we can, and using these two premises, we can come to this conclusion. So this example demonstrates how reasoning can be used to deduce conclusion from some given premises that we have. In AI, such reasoning forms the basis for knowledge representation as well as decision making in rational agent. Later, we will study several algorithms for this branch. So there are several fundamental questions in the development of AI problems that deal with knowledge representation, reasoning, and planning. Let's try them one by one and see how we can solve them. The first one is, how do we describe the current state of the world? The world is the environment of our problem. In AI, the world state can be described through state variables as well as state representation. These are set of variables that capture key information about the environment at any given time. The state can be represented either explicit or implicit. What it means? Explicitly, it means using a set of known variables or facts that are used to describe the state of our system. For example, in a robot navigation task, the state could include variables such as position, velocity, and battery level of our robot. On the other side, what is implicit? We want to try by maintaining knowledge through logical predicates. For example, robot at position X and Y, door is open, door is closed, which are updated as the world changes. So in here, we try to deal with world model, or you can say the environment model, and these are typically maintained to help describe the current state, which is a snapshot of the agent understanding of the environment at any given time. The second question is, how do we infer from our perceived knowledge and unseen parts of the world? In AI, agents rely on inference mechanisms, and they use such inference mechanisms to make educated guesses or predictions about parts of the world that they cannot directly perceive. This can be done using several approaches, including deductive reasoning, probabilistic reasoning, and heuristic. So what is deductive reasoning? In deductive reasoning, we use some logical rules to infer new facts from known facts that we have. For example, if the agent knows that all birds can fly and observes that animal is a bird, it can infer that animal can fly. The second one is probabilistic reasoning. In here, we use models like Bayesian networks to handle uncertainty. And we have some given percepts. AI system can use these probabilistic models to infer unseen parts of the world with varying degree of confidence. And the last one is heuristic. In some cases, AI systems use rules or patterns from previous experience, or you can say data, training data that we have, and we use the previous experience or training data to infer missing information. This can be particularly common in machine learning models where unseen data points can be predicted based on the patterns that we have. The next one is, how does the world change as time passes? The world changes through actions. The agent is in one state, it takes an action and it will be redirected to the new state. To model this, AI system needs to account for dynamic in the environment. So we can say that every action that an agent takes results in transition from one state to another state. This can be captured by a transition model, and the transition model is used to specify how the state of the world involved when a particular action is performed. Also, we have temporal logic and Markov decision process that we will discuss later. The next one is, how does the world stay the same as time passes? Which is known as the frame problem. The frame problem addresses the challenges of specifying what remains unchanged in a dynamic system when an action occurs or when the agent takes an action. When an agent takes an action, many parts of the world may remain unaffected, but it can be computationally expensive to explicitly state all these unchanging aspects. So the next one is, how do we know the effect of the agent action, the qualification and ramification problem? The qualification problem is determining the condition under which an action will have a particular effect. For example, in some cases, actions may have unintended consequences, and defining all the conditions under which an action will succeed is very difficult. Example, if I push the button, the door will open. This assumption may not hold true if certain conditions are not met. For example, the door might be jammed. Then, what is the ramification problem? Ramification problem refers to the issue of determining all the indirect effects that an action might have. For example, if an agent pushes a button to open a door, the agent may also inadvertently cause the lights to turn on or trigger an alarm. These questions are fundamental to designing intelligent systems that can reason about the world, making decisions, and plan effectively. While these issues pose significant challenges in AI, they also lead to deep insight into knowledge representation, reasoning, and the complexities of modeling dynamic environments. Here are some keywords in this branch: knowledge, reasoning, and planning. The first one is logical agents or fuzzy logic. In here, we use approximate reasoning to handle uncertainty and also how to make decisions in complex environment. Then first order logic, it's a kind of formal representation of knowledge using objects, predicates, and quantifiers for reasoning. The next one is planning and acting. AI systems normally generate a sequence of actions in order to achieve goals based on available knowledge. Next one is knowledge representation, structuring and storing information so that AI system can reason about the world. Then next one is inference, deriving new knowledge from existing facts using some logical or probabilistic reasoning. The next one is epistemology. Epistemology is the study of knowledge acquisition, reasoning, and the limits of AI understanding. Next one is ontology. This ontology is used to define a structure framework of concepts and relationships within a domain to support reasoning. And the next one is probabilistic reasoning. This probabilistic reasoning handles uncertainty in AI system using probability theory. For example, Bayesian networks. And decision making, selecting the best course of action based on available knowledge, reasoning, and predicated outcomes. So we studied problem solving by search. We came to knowledge, reasoning, and planning. And this one is learning. Learning from examples, learning from experience, knowledge in learning, and learning probabilistic models. So in here, we're dealing with the world of machine learning. So these days, everyone thinks that AI is only machine learning. But AI has different branches, and machine learning is only one branch of AI. So machine learning focus on developing algorithms and systems that enable machine to improve. So learning means improve. Improvement over time based on what? Based on data or experience. And we don't need to do explicit programming. Machine learning is a very hot and impactful area in AI, and it is used widely across various domains: healthcare, finance, transportation, robotics, everywhere. So, but the problem is, what is learning? In the context of AI and machine learning, learning refers to any process through which a system improves its performance over time, primarily by utilizing experience or data. So this can be pattern recognition, this can be prediction, understanding complex systems based on heuristical data. So machine learning is how to learn, how to improve. There are three main categories: supervised learning, unsupervised learning, reinforcement learning, and one in between them is known as semi-supervised learning. We will study them all later in details, but what is the difference between supervised learning, unsupervised learning, and reinforcement learning? Suppose a kid wants to sort out these color blocks. In the case of supervised learning, we will tell him that we want to take out red, green, blue, and yellow. It means we have some labels if these are data, right? So we know that how many types of blocks are here, then we ask to classify them. Okay, but here in case of unsupervised learning, we have data, but we don't have labels. So the kid needs to sort based on color. For example, he first finds red colors, then he see, okay, this one is not red, it's blue. So we have one cluster of red, then one cluster of blue, one cluster of yellow, one cluster of green, right? Like, but in the case of reinforcement learning, we have a supervisor here. The supervisor giving feedback to the kid if he is doing good or bad. Later, we will study them all in details. And the last but not least category of AI is communication, perceiving, and acting. So in here, we have many branches. One of famous one is natural language processing. So these days, we have too many chatbots like ChatGPT, DeepSeek, Google Gemini, Bing, Grok, and many others. They are like natural language processing models. So these are some sub-branch of AI. And in here, we want to help AI agents to understand, to interpret, to generate human language, to talk with us, to listen to us, to write for us, to read for us, and all of them. So natural language process allows machine to engage in human-like interaction through text, speech, and effectively bridging the gap between human communication and machine understanding. So human talks to machine. For example, you are talking with Siri, the machine captures the audio, they can talk with you, we have conversation, processing the text, analyzing, summarizing, data to audio, machine response. So human speak to machine. In here, human speak to machine, the process begins with the human user speaking or typing into the machine, and the input could be in form of spoken language like speech or text or even image, right? And in here, capturing audio, if the input is spoken, the machine uses mics or other audio sensors to capture the audio. Then the capture audio is typically as continuous waveform for them. Then they will convert to digital. Then they try to extract, and the several process they will do on it, then try to understand. So later we will study them in details. Then audio to text conversation. If the input is in form of audio, speech recognition algorithms are used to convert spoken words into text. These systems rely on acoustic models, language models, and various signal processing techniques to accurately transcribe the audio into written form. For example, voice assistants like Siri, Google Assistant, they try to convert our spoken words into the text. Also, we have processing of text data like text understanding, text processing. Once the text has been extracted, natural language understanding comes into play. This step involves understanding the meaning and intent behind the input text. So the machine here may tokenize the text, it means breaking it down into words or phrases. They try to identify the entities. For example, if there is name, location, time, currency, something like that, right? Then they try to recognize the syntactic structure, for example, grammar rules. Next, they identify sentiment or emotion expressed in the text, emotional recognition. So the system may use machine learning algorithm, linguistic models, or deep learning techniques to perform these tasks. The next one is data to audio conversion. If the system needs to respond verbally, it uses text-to-speech, that is known as TTS, text-to-speech technology, and this text-to-speech technology converts the processed text data back into audio form. So this TTS system converts structured text into spoken words using pre-recorded human voice. For example, TTS systems convert structured text into spoken words using pre-recorded human voice. For example, virtual assistants like Alexa that respond to our queries in spoken language. And then machine respond to human. After generating the response, either text or audio, the machine presents the output to the user either by displaying text on a screen or playing the audio response. For example, when we ask a virtual assistant a question, this processes the question and respond either by speaking or showing text on the screen. In here, we are dealing with various components in NLP, for example, speech recognition, natural language understanding, natural language generation, text-to-speech, and there are many applications that we will see later. The next one is AI vision. Also, this AI vision is known as computer vision, or CV in short. This is a subfield of AI, and the focus here is on enabling machines to interpret and understand the visual world, like what we see. So this vision or perception involves processing, analyzing, and making sense of image and videos. The key tasks of computer vision are rooted in enabling AI to perceive and also extract meaningful information from visual inputs such as image and audio. For example, it can be used for object recognition, face recognition. It can be used for scene segmentation. It can be used for image classification. And there are many applications for each one that you can think of. For example, autonomous driving, Tesla cars, robotics, medical imaging, right? These are all applications of computer vision. And the last one, but not least one, is robotic. So robotic is a multidisciplinary field that combines the principle from various engineering and scientific disciplines to design, build, and operate robots. The goal is to create machines that can assist, perform tasks, or operate autonomously in real-world environments like Tesla robots or Boston Dynamics robots. This robotics brings together diverse fields including mechanical engineering, electronic engineering, information engineering, computer science, psychology, etc. In robotic, mechanical engineers design physical structure, motion systems, and actuators. Electronic engineers develop circuits, power systems, and control mechanisms for robots. Information engineers ensure that robots process and communicate data efficiently. Computer science creates the algorithms, software, and AI that allows robots to perform tasks autonomously. And also psychology. In here, the psychologists study how humans interact with robots and how robots can simulate human-like behaviors or assistant human in different contexts. What are the applications of robots? For example, Mars rovers, autonomous cars, maybe in airports they can help each other, for surveillance camera, for industry. So we have too many applications here. So later we will study all in details. Robotics continues to evolve rapidly with interdisciplinary advancement paving the way for more intelligent, capable, and efficient mechanism. In this lecture, we studied 4 main branches of AI. I hope just it give you some general understanding of branches of AI, and in the coming lecture we will study algorithms more in details, and also we will code them accordingly. Thank you very much for your attention, and please feel free to contact me via this email if you have any question, comment, or concern. Thank you.